Gentlemen, welcome back. I know I've been teasing this series of videos for a really long time now, and I'm really sorry, but we're actually gonna get into the meat of it. I wasn't 100% sure how I was going to make the SEL 751 Masterclass series. I knew it wasn't a quick process to script and plan and obviously shoot and edit. It's a lot of information to cover. I started filming about 6 times and then scrapped the whole thing and started over. So genuinely apologize for that. But without further ado, here we go. This is the first, or really the second part of the SEL 751A Masterclass. We're gonna go through every single protection function available on this SEL 751A that I have. I know that there's a couple functions in the SEL 751, the non-A model, the A model is like the cheaper one, that aren't available in this, or at least in the unit that I have, notably like sync check and then RTD inputs. This one doesn't have that. So if the series does well, let me know in the comments if you want to see it, and I will buy another 751 off eBay and we'll make more videos for you guys. The elephant in the room is that this is a very long series of videos. Part of what took me so long to really get a solid set of scripts together and really start shooting pretty consistently on this is trying to keep it concise and split up in a way that's logical and easy for you guys to follow along with. I'm gonna have a long playlist of everything in the 751 series. As I upload them, you guys will be able to see them. Every video, I'm gonna try and keep it like 10, 15, 20 minutes at most. Only covering just a couple protection functions, a couple things. Obviously the first couple videos are really just how do you get started testing relays. This video, we're gonna cover what stuff do you need. Let's talk about test sets, we're gonna talk about software, we're gonna talk about tools, things like that, the condition that the relay needs to be in, and the settings. The next couple videos, we're gonna talk about SEL logic, specifically the SEL logic that you're gonna find in a 751 or 751A. How to pick through the trip equations to determine what you actually need to test, and then how to get the relay into a state that is suitable for you to test. So, like I said, shorter videos, easier for you to find the element that you're actually looking to test as soon as they're uploaded. It's gonna be a long process to finish editing and uploading all of these. They'll be separated sort of by function and by how hard they are to test more than anything. The series is gonna get more complicated as we go. And then shorter videos, because obviously YouTube ad revenue is a thing. And if you find this series of videos helpful, I would definitely appreciate it if you subscribe and consider joining the channel membership for as little as $2 a month. It goes a long way to help me make more of these videos. I would like to mention that I've got a few relevant videos already up, and I'm gonna try and repeat myself as little as possible here. I covered downloading the SEL settings files, specifically out of this particular relay, but it's applicable to most SEL relays, in a previous video, which I'll link somewhere up top, and then it'll also be linked in the description, maybe in the playlist. And then I also have a 45-minute tutorial on how to get started using ProtectionSuite. That's the relay testing software that I use. Again, I'll be trying to explain all of this as agnostic of the test set and software as possible. So if you're using RTS, if you're using Omicron Test Universe, I'm gonna try and have it make as much sense as possible for you so that you can make a test plan on any piece of software. I'm gonna assume that a good chunk of you guys are watching this on a cell phone, in a porta-john, at a job site, and as soon as you're done watching the video, you're gonna go sit back down at a test set. So my opinion of your choice of test set probably doesn't matter, but I'm gonna tell you anyway. There are a bunch of really good relay test set options out there. There's a couple not so good ones. More than likely, you're going to just be assigned one from the company that you work for, and you're gonna be stuck with that because that's what your mentor had, or that's what they have in the shop. And once you get used to that, you're probably just gonna stick with that relay test set until you have a really compelling reason to change. You grow out of its limiting features, or maybe you change jobs and go somewhere that doesn't have the test set that you know how to use. Number one in my book is the Doble F6150. You've seen me talk about it quite a bit here on the channel. I've been using it for 11 or 12 years. Doble seems to be sort of the king of the hill in terms of most popular among utilities here in the United States. And Doble even made a newer relay test set, a more modern one. It's got some features that help you with digital substations. They call that the F8300. I checked it out. I don't think that it lived up to my expectations. It didn't really live up to some of the marketing claims. Just got kind of some little gimmicky lights. I wasn't a huge fan of it. Doble even reached out to me and asked if I would like to see another sample unit now that they've fixed a bunch of the issues that I complained about in the firmware, a bunch of issues I had in the software. They've got some updates now, and they say all my complaints have been addressed. Yeah, I just kind of ghosted them. It was really nice of them to offer. Maybe I'll take another crack at it someday soon, but for the bulk of this series, we're going to be using the F6150 with ProtectionSuite. Either of the Doble relay test sets, the 6150 or the F8300, they're really solid choices. The hardware is going to do what you need it to do, and the software, I'll be able to show you how to do that. I'll be able to show you how to run the software perfectly well. Next up, if I had to start over with something other than what I'm currently used to, the Doble relay test set, I would probably pick the Omicron. So Omicron, the CMC356, is a very, very widely used, very widely respected, convenient relay test set, and its recent predecessor, the brand new CMC500, is likely the best hardware choice as far as like current voltage outputs and stability and not blowing up when bad things happen. I got a video talking about shit blowing up here. Omicron probably makes the best hardware on the market. I'm not really used to the software end of it, which we'll talk about later. So it's really hard for me to make the switch. But if you were going to buy one, either the Doble or the CMC are going to be really strong choices. Doble owns a subsidiary company called Manta Test Systems that make the MTS5100. That one is actually really cool for some things. I prefer that for a handful of oddball things we're going to do out in utility substations because it has a built-in screen. You don't need to use a laptop and special software to run really basic tests. If I'm just doing like a ground fault test for like a ground fault relay in a low voltage switchboard or something like that, or just doing meter checks, the MTS5100 is a fantastic unit. I have no complaints about that, but I find it's a little bit limiting with their Manta's proprietary software for it. And it's not super convenient for some of the more advanced tests that we're going to get into, even on the 751. You can make it work. It's just not my favorite choice. Lastly, there's the Megger SMRT 410, or a lot of people call it the Smart. If you're stuck with a Smart, I'm really sorry, but it'll probably work. It'll probably do what you need it to do. If you're considering buying a Smart, maybe consider something else. There's a few other relay test set options out there on the market. If you're not running one of these, you know, the 4 or 5, the Doble, the Omicron, the Manta, or the Smart, best of wishes. I really wish you luck. I got nothing for you. Obviously, if you're watching this in Europe or in India or in Canada, as a lot of my viewers are, you're going to have different options. All right, so the test set that you have usually dictates which relay testing software you're going to use. There is a program called RTS, which recently got bought by Doble. Doble's buying up everybody. RTS can run on any test set above. There's a whole laundry list of them on their website that the RTS software can run on. It is a separate automated relay testing software that basically takes over the connection between your laptop and the relay and your connection between your laptop and the test set. And it runs everything kind of automated. So if you don't know how to test relays, RTS can hold your hand and get you a bunch of green check marks, maybe get you out of a squirrely situation that you weren't really prepared for. The problem is that the industry is kind of flooded with a bunch of middle-of-the-road technicians that don't actually know how to test relays. And so oftentimes they're missing really critical steps in the relay testing procedure just because they don't know how to do it, or the software hangs up, or it's a custom function that they don't know how to make in RTS. And so stuff that's potentially pretty easy that I could walk you through in a, you know, a 5-10 minute video is going to get skipped. And that's an issue. It's a noteworthy issue. I wouldn't recommend someone just starting out running RTS on every relay. Again, great in a pinch. It's good to have an RTS key. Some utilities actually require RTS, so that's worth noting. But I think you should learn how to test relays correctly and apply those theories. And if you want to run RTS in the future, once you're a little bit better, you know what to look for. You know you're not going to miss anything. You know you're not checking a bunch of boxes and not really thinking about it. RTS is a pretty powerful tool. I don't think it's the best choice for most applications. Modifying the RTS plans can sometimes require you to use this really odd bespoke C+ fork to program the test plans. Just something to be aware of. Doble's relay testing software is called ProtectionSuite. That runs on both the F6150 and the F8300. It's what I've been using for over a decade now. I like it for the sole purpose that I passed the learning curve and I'm really fucking quick with it. It's probably not the best software out there, but I know how to use it really, really well. It's pretty easy to make really advanced test plans, advanced relay test plans. The macros kind of simplify the process of simulating really complicated faults on a power system and make it possible to thoroughly prove all of the possible combinations of protection and logic and everything that you're going to find in literally any relay. I have no software limitation complaints about ProtectionSuite. I think ProtectionSuite is pretty good. Everything I just said is basically also true of Omicron's test universe software that you would use to run the CMC356 or the CMC500, except that I just never learned how to use it. So maybe someday I'll make some videos about it. PowerDB is really popular in the industry as a test sheet database software. What basically every testing company I've ever worked with has used to manage their apparatus test forms, not necessarily for their relay test forms. It has a really crappy relay testing plugin, and that's what you have to use to run the SMORT, the Mega SMRT 410, unless you have an RTS key. Cables, adapters, and tools. I've covered all of this previously, and I'll call out what stuff I'm using as it appears in videos. So I'll try and keep this section a little bit more brief. You'll want a good precision screwdriver set. I really like this one insulated one from Weha. It's got the small little tweakers and regular screwdrivers. You're always going to want to keep USB cables, probably an A to B, that little printer looking cable, as well as, well, nowadays, USB-C from whatever your laptop is. If you got USB-C ports on your laptop, you would want USB-C to USB-C, as well as USB-C A to B, and then USB mini and USB micro. You don't have to keep all the cables. You can get a little adapter kit. I got some cheap one off Amazon. It works great. I'm not saying the cheap $5 set you're gonna buy is gonna work great, but you know, it's worth a gamble on. You're also gonna wanna have, if you do a lot of SELs, you're gonna want a SEL C662 cable. And then I always recommend having a Cat6 Ethernet patch cable to go between your laptop and the test set, or to potentially relays that don't have a serial port. The test set that you bought or rented should come with flexible test leads. These generally use 4mm like spring-loaded banana plug jacks or banana plug leads. To connect the test leads from your test set to the relay, you're gonna want, I'm just gonna put pictures of them up, you're gonna want banana plug to fork lug adapters, as well as for these smaller little Phoenix plugs, I really like having the banana plug to just like a solid copper wire adapter. Those are really, really handy. They'll get you out of a pinch more often than not. Alligator clips that have a banana plug end on them are also, I always have them on my truck. They're super, super handy, but they're generally not the first thing that I grab out of my bag if I'm trying to hook up to a relay like this. If you're gonna test a lot of relays in the field or do a lot of substation work, get at least 2, preferably 3 test switch paddles. The most common ones in substations in the US are the ABB Flexitest layout. Those are really popular. You don't have to buy the ABB ones. The test switch paddles that ABB sells are like 3 or 4 times more expensive than they need to be. I really like the States JTP10 test switch paddle. They're a little bit flatter, they're easier to carry around, and they're more robust. The plastic's a little bit tougher, and the plugs on the back, they're flat so they don't stick up quite as high. It's just easier to get more wires in and out of when you're actually using them. More info will be linked on the screen and down in the description. Okay, let's talk about the condition the equipment actually needs to be in. This relay right here, it's on my bench. There's no wires connected to it. It's also off. So to test it, I would need to turn it on. I need to put power on it, either from the power supply simulator output of my test set or from a little benchtop power supply, something like that. There's a very good chance when you go to test relays, you're gonna be in the field. You're gonna be at a substation, switchgear, big MCC, something like that. The relay is gonna be on. And so you need to be aware that the terminals back here are probably gonna have 120 DC on them, or 120 AC, or 240 AC. And so touching any of these, even though they're plastic and they're all covered, they look like they're touch safe, be really careful about that, because you can not only shock yourself, but worse, backfeed power into your test set, blow your test set up, or backfeed power somewhere that you don't want it. So it's really, really critical that you guys are completely aware of the condition that the relay is in before you start testing. If the breaker that your relay controls, or the circuit that your relay is protecting, is energized, and you're watching this video for advice, just assume that you can't test it. If the CT secondary circuit opens up while you're moving test leads or unlanding wires to the relay, you can really fuck shit up. You can destroy the CTs, you can damage the circuit, you can make it basically to where you're not gonna turn it back on today. If you aren't trained and skilled enough to correctly identify the condition of not only the relay and the circuit, but all of the circuits that are connected to the relay, just back away slowly, put the screwdriver down. There's no shame in asking for help. There's no shame in coming back once we know that everything is safe and de-energized. Trust me, it's much better to not do something than it is to do something wrong and blow shit up. Outputs from a relay such as this can have their tentacles wired into really seemingly unrelated systems and shoot trips upstream, downstream, and clear a whole bus. A breaker failure trip can accidentally turn a single circuit maintenance outage into a plant-wide blackout that lasts a week. Ask me how I know. It's really, really embarrassing. Now, the audience of this video is
exclusively male, 60% in North America, between ages 25 and 54, 74% are not subscribed yet.
Further, you may or may not be an engineer, and that's fine. I'm gonna say something that should be less controversial than it actually is. If you're a substation tech or a needed tech and your name isn't succeeded by the letters PE, you don't get to make settings. Full stop. The engineer of record is responsible for making the settings or paying some other engineer who's smarter and better looking to make the protection settings. You, as a technician, are responsible for making sure that the relay settings in here work. That's it. You do not make the protection settings. The company that employs you doesn't want the liability that would come from you generating a protection settings file. I guarantee it. Now, if you find an obvious issue with the relay, this overcurrent element doesn't make sense, this pickup setting doesn't work with this relay or doesn't match up with the CT ratio that's actually in the switchgear, that's totally fine. It is your responsibility, once you notice that, if you're even paying attention, it's your responsibility to bring that to the engineer of record or bring that to the coordination study engineer and ask for an update. Ask those leading questions. Hey, I think you got the CT ratio on this wrong. Here's a picture of the CT nameplate. Here's a screenshot of the settings. Would you like me to change this for you? Yes or no? It needs to be in writing. Don't just go change settings. If a customer asks you to make settings in the field off of a coordination study document, or they ask you to test generic factory default settings or something like that, calmly but firmly tell them to fuck off. You can come back at a later date with a signed change order and a correct settings file and redo it then. You as a technician do not get to write relay settings, period. Well, boys, I think that's it for the prerequisites of testing an SEL 751A relay. Stay safe out there. Make sure that you're subscribed so you don't miss it when I post the next little knowledge nugget for y'all in this series. I'll see you on the next one. Thanks.